staying focused of like, what is the core thing that we can do so that we have a really core, powerful niche that we're really good at, and then expand from there in a controlled type of way. And over time, it was just adding square footage, which kept on happening.
Welcome to the Reality Capture Network, where we focus on technology-driven innovation, education, and community. The Reality Capture Network, bringing the future to you. On this episode of the RCN Podcast, the CEO of Slant 3D, Gabe Bentz.
I grew up on a cattle ranch in Eastern Oregon. I ended up becoming an engineer, and that's not generally what people anticipate with that of working in high tech after coming out of a real rural place. I was introduced to printing probably about the 2012, 2013 stage when it was first kind of becoming really kind of consumer focused. And we created this little product where we just threw it out there and kickstarted it, but it was pretty successful. And it was these little STEM robot arm kits. In the process of building that first print farm gave us some insights to the fact that there was a roadmap to make this more useful at scale.
The people who could build the robot may not think of this use case, but now that it's getting to a certain point, they want to adopt it. Maybe with printing, we see it with scanning and with drones.
You no longer have to do inventories. You no longer have to order 100,000 pieces, keep them on a warehouse shelf for 10 years until they all sell out. You can just say, need a part, and the part ships out and ships to the customer. And it becomes a warehouse where the shelves make the product.
All right, welcome to another episode of the Reality Capture Network podcast. Today, we are excited to have another local here to Boise in studio. Welcome, and thanks for joining us, Gabe.
Hey, Matt. Thanks for having me. This is going to be fun.
Yeah, we love, in studio is my favorite. Virtual, it's nice, it's accessible. We get to talk with people all over the place. But getting in person is a lot of fun.
Yeah, it's a lot cozier than like a laptop sitting on your
It's
your
very
lap
personable
there, right?
too. Yeah.
This is a lot more fun.
Again, thanks for coming in. Excited to dig in. In fact, you work in an area that we've not really talked about a lot, and I think is current, relevant, and I think that a lot of people are outside the loop on. They don't know a lot about it, and I think there's a lot of applications for it, and that is 3D printing. But before we get deep into that space as normal on the podcast, I like to go back into the story a little bit of the guest and hear, kind of like the background story of what you grew up around and that journey of what inspired you and kind of where you got into your, line of work.
Okay. Well, I was born on a dark and stormy night long ago, and the doctor looked at my dad and said, "It's a boy." Well, we probably don't need to go that far.
That's good.
But yeah, I grew up on a cattle ranch in Eastern Oregon. Originally, so large family, 5 kids there, but grew up in a super rural area of Oregon, which is odd because you wouldn't think. I ended up becoming an engineer, and that's not generally what people kind of anticipate with that of kind of working in high tech after coming out of a real rural place.
Yeah. No, you didn't stay with the ranching and
didn't stay with the ranching thing for very long there.
Yeah, that's awesome.
Yeah, I think I probably, the first kind of like spark for it all was probably when I was like 5. And I'm going to date myself here a little bit. I'm still a millennial.
That's all good.
We watched really old movies, and like the old Lost in Space TV show, like the old black and white, super campy, silly one with like a guy in a suit.
I don't think I watched that one.
That's fair. It's from like the 1960s or something like that. That's totally fine. But they had a really cool robot on it for a 5-year-old kid. And I was like, I got to do that.
That's cool.
So I was really lucky to kind of figure out what I wanted to be working on pretty darn early on. I pretty much worked for that the whole time, and except for like one crazy year when I wanted to like be a dentist or something. But.
You get through high school. Like, what was some of your first jobs?
I didn't really do a job related to my interest until like internships in college and that kind of stuff.
Okay.
Because throughout high school and everything else, it was always like working on the ranch.
Yep.
So you do what you got to do for the summer to pay the bills and save up for college and that kind of thing. The first job that I did that was career focused, I worked at a product consultancy in Corvallis, Oregon, where we did a lot of stuff with HP. So we got to work on all kinds of cool stuff there. And one of the projects at that later on, I got to end up working on the Microsoft smartwatch, which we all know is such a big winner.
Oh, yeah.
Yeah, exactly. We're all using them now, of course.
Hey, they all got to start and, give a shot at them. And
everybody was taking their stab at that time. But that was kind of the first one around, and I liked the idea of the creation process early on, which is one of the areas that I'm most interested in, because management and growing the thing is fine, but it's fun to just kind of invent and work on a thing and solve those kind of core problems. It's way more interesting.
Yeah.
To me, at least.
Yeah. Okay. So what was the rest of that, the next steps that look like, as we start working toward where we're now?
While I liked the process and the active engineering and design and that kind of stuff, I hated the other components of it, which were kind of the way engineering was being taught was really irritating to me, and the expectation of what an engineer was supposed to do in many cases was irritating to me. There were the sparks of fun of, okay, go design, work that problem. And then the rest of the time was like sitting on CAD for like 8 hours a day. And I was like, I don't really feel that. I want to be on the floor building the thing, so on and so forth. So in rebellion to that, I ended up dropping out of school for a year and going and just working on other stuff. And I did a bunch of writing, a bunch of freelance stuff, all kinds of things, just wandering around. And during that year, I did everything from sales to whatever it happened to be. But what I did after that, after I got all of that out, the rebellious
which
stage,
is great for people to do.
Exactly. I actually did go back and finish the degree in engineering, because at that point I kind of settled into like, okay, it's good. I'm in the second half of the 2 years. I'm going to knock that out and be done. Ended up finishing the degree. And then I immediately went into, during the time at school, myself and a few friends had created a product design consultancy where we just did design and expectation and basic engineering for folks who were early on in the stages of the design of a product. And we kept on going with that when we got out of school.
Nice.
And then I moved up here to Boise at that time because we were able to do remote before remote was cool.
Nice.
So we had one guy in Hong Kong, one guy in Texas, and me up here in Boise. And while we worked on that stuff on the side, when we didn't have client projects, we kind of work on our own projects, and those would create little businesses and product lines and that kind of stuff that were fun to mess around with.
Nice. Can you, on both the things you're working on for clients and side projects, could you tell us about one that comes to mind or something you enjoyed working on?
Let's see. I don't know about the client projects. I can't speak to those very often because it's tough to love a thing that's not yours really often.
Yeah.
Most of the projects that we worked on that were a lot of fun were we were all kind of robotics engineers in that kind of area. So my whole field of discipline was robotics, and more specifically kind of consumer-focused robotics, so like interface and UI and that kind of thing. Which is a wildly hard problem. If you want a miserable problem, it's trying to make a robot that people like at all.
Oh, there you go.
Because there's Tic-Tac wandering around on your floor, and then there is walking humanoid robot butler that can't possibly exist right now. And there's nothing in between that's useful to anybody. That's not a camera wandering around inside your house that scares everybody.
Yeah. It's following me.
Yes.
Yeah, no.
So working with those projects was fun. We one of the big projects that we had messed with was actually the idea of the robot butler, of like, can we create a platform that is able to manipulate inside of a human environment and do something useful? Be a mobile robot, can open a fridge and reach up on top of the counter and is not the hockey puck wandering around on the floor. But can actually do something useful and do it in a way that's easy enough and reliable enough to where other people could build applications around it. Because our theory was kind of, if you have a body that is reliable and consistent and sitting there that can operate and do the things that a person would expect a robot to do, then the software can get caught up, because the software gets to move on a completely different trend than hardware, and there's just not hardware out there to like build stuff for. So you wanted a $100,000 robot body or something like that, whoopity-doo, but that's not really going to get a lot of consumer adoption or build any sort of stuff around it. So we wanted to build a really affordable but capable robot body that had all the capabilities that you needed. And this was like 2015, 2016. So it was very on trend at the time, because we were back in the early version of the AI hype, which was the machine learning hype. And we were all sure we were going to die from software for something back then.
I think we're back there now.
Yeah, it comes in 5-year cycles. But yeah, 2 years before that, it was all the AR, VR stuff again too. And now we're back in that. So same horse, different color. But yeah, that was a lot of fun to work on, was those projects, because for me as a mechanical engineer, it's a lot of fun to work with how do you make a body that's capable.
Yeah.
But then from the software side, it was how do you find the kind of fundamental truths and how to make this thing appear to be thinking and doing something useful without getting into the weeds. Because in the field of robotics engineering, which nobody cares about, it's just super highly defined and mathematical, which means that you know exactly right here, you move exactly to right there, which is a terrible way to build a robot for the real world, but it works fine for car factories.
Yeah. Man. Well, and being in that field, I'm sure you also watch what is being built or what else might be out there. When are we going to get a butler?
We've been able to do this for a long time. The reason is it's not really the technology anymore. We can do it. It's actually more of just the customer acceptance of like what is kind of the killer app and the killer project that makes it compelling to people.
Yeah.
Because it has so many humps to get over of like, robot wandering around inside your house that has cameras on you, that's probably owned by Amazon or whatever it happens to be. So can you trust it? And then what is the fundamental use? Because there's like vacuuming your floor, and then people always go to like doing your dishes. But like really, that's really not that big of a deal to like get a dishwasher.
$100,000 robot dishwasher.
Exactly. Something that costs as much as a car or something like that. It has to be a full human almost in order to be useful. And even in that case, not very many of us really need a maid wandering around the house either or anything like that. So just the applications of where the real utility is of a personal robot is kind of up in the air, because the market just isn't, we don't know what the killer app is. Like when personal computers came out, nobody knew what the heck to do with those either, because nobody needed that. Nobody was keeping a ledger and hand cranking stuff all day. But then businesses started taking it on for spreadsheets, and then they started building some computer games and that kind of thing, and they started getting some acceptance. But there hasn't been that roadmap for like personal robots.
Which is like you talked about, it's kind of that process, something gets to a certain point, you build the robot body, now other people will figure out what to do with it, or the software, or the...
Right, that's a terrible business model.
Yeah. Yes, it's terrible. But as we see technologies improve, it lets other businesses and other people start thinking of that process, and maybe an industry that the people who could build the robot may not think of this use case, but now that it's getting to a certain point, they want to adopt it. And we see the same thing maybe with printing. We see it with scanning and with drones, and with is the drone is now there. The drone can now hold more sensors. And now so other industries are that maybe we as service people wouldn't think, I didn't even know we should map a rooftop for solar planning, or I didn't know we should put a thermal camera on it to look for cold spots on a warehouse, for energy efficiency. So as we look at new technologies, it opens that door for maybe use cases we didn't even know were out there.
No, yeah, exactly. And this is like the case with like the Spot robot dog.
Yes,
and that kind of stuff.
Right now it's just a...
You're right. He's wandering around. He's an RC car with 4 legs. But he enables so much stuff.
A hype dog.
Yes.
Picture taker. Selfie dog.
Man, those great videos though. Man, you couldn't have a better thing for showing off.
Attract the crowds. Yeah. Okay, so robotics, we had the startups, we're kind of dealing with side projects. So what was after that?
About 2016, 2017, by accident, over the weekend, I created basically a small little robot arm kit that I was messing around with, because we had a printer in the office, so I knocked this thing out, and I had a printer at home. Okay,
so before we get there then, so when did you first get introduced to 3D printing then?
Actually, I was introduced to printing probably about the 2012, 2013 stage, when it was first kind of becoming really kind of consumer focused.
Okay.
And it was garbage.
Yeah.
I hated printing for a long, long time. I mean, through school and through whatever work I'd done through there, I was never a fan of printing. Because the thing that irritated with me about it was so often my peers would be like, "Oh, we need a plate with a hole in it. Let's go ahead and print it." because that's the thing. And I'm like, how about we just go cut out a chunk of wood and drill a hole in it? And I just, so it bugged me that it became this catch-all of kind of laziness of like, we can print it. Well, that doesn't mean you should. So I was never a fan of it, and the results from it were really garbage. But it was great for a prototyping process if you wanted to get a shape out really quick, but it was also really expensive. The fidelity wasn't very good. Everything about it was irritating, complicated, and miserable. And like the personal machines at that time were just irritated, complicated, and miserable. Yeah. And for some reason we used the material ABS, which is irritating, complicated, and miserable. There was nothing about it that was helpful or useful in any sort of way unless you just really, really wanted to fix a machine all day long. Like a hobby would. But my goodness, it was terrible.
Alignment or clogs or whatever. Or
all the stuff. Everything could go wrong.
And yet you then got into it.
I was forced into it. Okay. I don't want to at all. Because we created this little product where we just threw it out there and like kickstarted it. And we were like, this isn't going to do anything, whatever. We'll get done with this and we'll move on to the next thing next week. But it was pretty successful, and it was these little STEM robot arm kits that we designed to be printed because we thought we're not going to move any of these things. We'll print 12 of them or whatever it was. But it was pretty successful, and we ended up having to build kind of a print farm to produce these because building the print farm was still cheaper than buying the stupid molds or redesigning the whole thing, and we thought the whole thing was going to be done in a week. But we, in the process of building that first print farm where we basically just bought the cheapest machine we could possibly find, and got 6 of them lined out and started printing. And it was just as miserable as we thought it was going to be. But having them all lined out there kind of gave us some insights to the fact that there was a roadmap to make this more useful at scale. Because when we looked at printing, we're like, okay, well, why is printing more expensive than molding? Why can't this scale up? Why is it so miserable? Well, obviously the machines are garbage. That's an engineering problem. It's easy to make a better machine. There's obviously better machines out there. And as far as like inputs, printing has fewer inputs than traditional manufacturing. You put in plastic and electricity and melt that plastic and turn it into a line, and then you grow the part. So that should be a perfect process technically because there's no waste or upfront at all. There's no mold. There's no tooling cost, none of that kind of stuff. So fundamentally, that should have been more efficient. So when we ran that print farm, we just stared at it and we were like, okay, what are the things really slowing it down? Well, there's no automation because some guy has to sit here, stare at it all day long. There's no tracking of it. Again, guy staring at it, put a camera on there, do a little bit of code and make the machine tend itself. Figure out how to make the machine reject or eject parts so that it can move on with life after it's done with a piece and not sitting for 24 hours until a guy comes by and shoves it off. Just these really silly, very solvable problems. And when it became nice engineering little solvable problems, it's not like, oh, we have to invent fusion and this will just work. It's just like, no, we got to clean that up, reinforce that, write a little bit of code here.
Which is what you guys knew how to do.
Right. It was really, really tractable, especially as a robotics kind of company. So we just started messing with it. So we scrapped those first 12 machines. We kind of started building our own and then just started iterating on that. And the benefit of it is that since that product line that we needed these machines for was pretty successful, it was kind of cash flowed, this little R&D project on the side of how do you make a print farm work well. And we were able to eat our own cooking throughout the whole process of like, it's not making good parts, it doesn't make them fast enough, so on and so forth. All the incentives were aligned to make sure we optimize this the right way, as opposed to, you got a print farm, come use it.
Were you start trying to actually build your own printers, or were you buying printers and iterating and add-ons, or what did that look like?
After the first off-the-shelf machine, we decided we had to build all our own machines.
That's awesome.
Yeah, there was no way to do it. Yes. It was really not what we wanted to do. But we looked at everything that was out there and we were like, none of these can do the actions that we need them to. They might be able to have quality, but they can't mechanically eject or anything along those lines, or can't be modified in that way. So the first 1.5 generations were off the shelf because we were just messing around with like architecture of like this type of machine, that kind of thing. But we almost immediately, on version 2, we started building them straight from scratch. Just because there were the very specific things that we needed that nobody had really put together into a box yet. So we just started pushing on that.
As somebody who has no robotics or engineering or design or programming knowledge, that sounds like a very complicated process to build good 3D printers.
Compared to a robot butler, it was a lot easier. Actually, it was a lot more helpful than it was, because most of our job when working with these machines is just boiling them down. Because since the printing industry has been focused towards consumers for so long, it's been about, okay, how do we bury stuff and hide things and box it up,
make it look pretty,
make it easy to use. And easy to use is fantastic for a user experience, but it's absolutely awful for industrial equipment where you need access and maintenance and ease of use and quick assembly and that kind of stuff. So we spend most of our time deleting parts and trying to kill stuff. Like a lot of our machines anymore don't even have a display on them. It's just like you're connected through the main control system and you see on your phone what its temperature is or something like that. So it just, over time, the machines have gotten a lot simpler, because all a 3D printer has to do is move in 3 directions and squirt out hot melted material. That's all it's got to do. It doesn't need to have a dance. It doesn't need to have a beep or bloop or any of this other crap that people put on it. It just needs to grow apart in 3 dimensions.
And so, obviously, I think 3D printing has grown to so many different uses and materials, and your guys' focus is around plastics and prototyping, or after you guys started building your own and kind of regrowing your own print farm, what was some of the first projects or adoption of actually using it after that Kickstarter and that first arm and stuff?
Really, since we were on Kickstarter and doing that, a lot of other Kickstarters started reaching out to us. So like one of our earliest clients was actually another robot arm company, because robots have so many parts in them that there's no possible way you can get tooling for them if you're starting out, because you'd spend hundreds of thousands of dollars to just get your first piece, and then you realize you screwed everything up.
Yeah.
So printing was really natural for a lot of those robotic startups at that time, and it was in the world that we were all in. So we were just called up a friend or something like that and said, hey, you got this thing. We got a bunch of printers now.
That's cool. So you're the Kickstarter prototype, Kickstart supporter.
Almost. Yeah, pretty much. It became a really good way to ramp up a new product for basically nothing.
Yeah, that's awesome.
So yeah, the first one we did was, one of the earliest ones we did was a company called Haddington Dynamics that made this big old long robot arm. And they raised $100,000 Kickstarter, and in 2020 they sold for $26 million. It wasn't bad for a 3D printing project.
Okay.
Yeah, it was pretty darn good.
That's pretty good.
So yeah, we're gonna take all the credit for that.
Yeah, all of it. We'll print it with some buy-in.
Exactly. Yeah, you gotta put a little "Made by Slant 3D" on the bottom of it. Yeah.
There you go. Very cool. So you started building. You did some starter projects. What did the next steps look like? Because you guys grew quite a bit, from that phase.
Yeah, we would double almost every single year as far as footprint for the factories there. Over time, there weren't really any ever big steps. I'm not a big believer in like, by golly, we're going to double next year and it's going to happen on Monday. It's more of like, just keep on chasing the little 1% each day, and you'd be amazed how far you can get at the end of the year. So there was never any big leaps really in the early stages of it. It was just like, okay, the machine's kind of broke this way. Let's update the design, do this. The clients kind of need this. Let's try to explore that. The biggest challenge kind of when we were starting out was how to have focus of like, what do we actually do? Because printers can make anything. Yeah. So what do you make?
Yeah.
And this is something we struggle with even right now. Because anybody can wander through our door and say, I got this and I got that and whatever it is, but it messes with our workflow.
Yeah.
And when you're trying to build a factories really like the same thing over and over and over again.
Optimize for something.
Yeah. And we're totally not doing that.
Yeah.
So it's really miserable in a lot of ways. But that's kind of one of the bigger challenges, and just staying focused of like, what is the core thing that we can do so that we have a really core, powerful niche that we're really good at, and then expand from there in a controlled type of way. And over time, it was just, adding square footage, which, kept on happening.
And for the most part, though, do you feel like there's been enough projects that you've not obviously you've kept growing, you've kept going, you're inching that, like you said, no big transition, but you just keep going. Do you see the adoption of it growing? Do you see the use cases from your side growing? Even though you haven't niched down on something, has that been a good process?
It's been a great process. There's certainly an education gap. The education gap is mainly, though, not really people thinking about 3D printing. Like, it's a thing in people's minds anymore because it's been around 10 or 15 years in public consciousness. But the problem is, once a person says, oh, I kind of want to look at 3D printing, in order to really take advantage of it, it is a different process from molding or machining, which means it has different rules and engineering styles and that kind of stuff. And so often people get in this like idea of like, oh, 3D printing is less than, basically kind of the way I was for a period. But it's not, it's just different. And if you learn how to design it and use it, it's as good as anything else. Saying it's less than is like saying, well, steel is weaker than titanium. Obviously, steel is a garbage material then. It's like, no, it's just different. It's why the application that it works for and engineer around it. So that's much more the challenge anymore, which is kind of the education and building up the workforce that is able to utilize it in an effective way without trying to 3D print an injection molded part where they're always going to be disappointed.
That's a huge thing, and we see that with all the technologies we focus on or talk about or use. For instance, I use laser scanning a lot because that's one of our big focuses. As the years have gone on over the last 12 years, we've gone from the only thing available is a $150,000 scanner to now your iPhone can scan. And then everything in between, a $10,000, a $15,000, a $20,000, a $30,000. But there's a lack of this education as to, well, what's the real difference between all of them? And that price difference and the ease of use has now made it say, oh, well, I tried someone, coming out and scanning this thing and it wasn't good enough. Well, okay, but you hired the cheapest guy with the entry level gear, and that's not an engineering level, product. And so I think our entire industry around these technologies, from scanning to point clouds to how we convert to models to printing to VR, like this whole process still feels early enough that people don't understand it thoroughly. And even the people that want to adopt it don't know where to begin and don't have that use case. And that's one of the goals we have with RCN, with a podcast, with a conference, is like, let's bring out people and have them do presentations about where they have seen success or where they're having struggles. And maybe someone else on a panel can give feedback, because if this panelist says, hey, I tried scanning and it didn't work, well, this one could say, ask the question. As you build a community around this type of stuff, the conversations happening, the best case scenarios, the case studies, the white papers. So even in the sense of 3D printing, we don't talk about it a lot. We don't have a lot of knowledge around it. The best thing we could do is say, well, let's find somebody that does 3D printing. Let's talk to them. Let's learn about it. Maybe they have case studies. Maybe they have white papers. Maybe they have project examples, which leads to the next thing we want to build, which we've already started, is an online education center. We want a go-to spot that people in any of these technologies can say, I'm trying to figure out how I would use 3D printing, or I'm trying to figure out which scanner I should get. There's not a lot of good resources out there that explain those things to you. You can start Googling and you get a million examples and different blogs, and the internet is full of stuff, but there's not a go-to spot that really has that good educational content. So we see that gap across the industry all over the place.
And it's really hard for these technical fields to build that kind of stuff because there's a bunch of engineers. They don't want to talk to people.
Yeah. And it takes time, it takes effort, and there's also some companies out there, as soon as they do figure out a use, they don't want to share it with people. And so, we're trying to break down some of those walls, but
that's fair. How, in your industry there, how often when somebody has a bad experience with a poorly informed or bad decision somewhere early on, what do you think is like the cycle time before they're willing to try it again, or their organization is willing to try it again?
Yeah, that's a good question. I would say it probably depends on how bad it was or how big it was.
That's fair.
I think if it's once, if it's twice, I think people start to learn why it didn't work, because there's enough content out there that maybe people are starting to ask questions. But there are definitely companies that in the last several years, we reach out to a client, we see a project, we're like, hey, this is a great application to come out and fly it with drones or something. And they're like, we've tried that before. We don't trust it. Like no thanks. We're just going to do traditional survey.
Yeah.
So it definitely happens, but it's hard to say. It's hard to say what that timeline would look like. I think the thing that I've personally learned is that the education helps them overcome that.
Yes.
And that's what I've personally built with doing this, with having conversations, with sharing case studies and showing project examples on social media. Mm-hmm. People who watch me and follow me for a couple years, and then they reach out and they're like, okay, we have a project coming up. We've seen that you talk a lot about like accuracy and you understand the different gear. And so I personally see that the education is what solves the problem of people that have concerns or that have reservation or that don't know if they can trust it. They need somebody to trust to be able to educate them and walk them to that point.
Yep.
And my goal with the educating also isn't, hey, I'm educating in order to get business. I'm educating because I see the gap there, but it also leads to business.
Yeah.
And so the next step is like, I'm getting so much business, I can't even handle it all. I have to build this network now to say, I'll educate you. I'll help you learn how to do it or what you need. And then if I can't do it directly, I'll connect you with the right people to do it.
Right.
But overall, it makes me just say, those of you who are out there that think you should keep it to yourself or think you shouldn't share, or you're completely wrong, and you will do better for yourself and the entire industry if you educate and if you share the failures too.
Yeah.
Share what didn't work.
Well, that's what builds the trust in it all.
Yeah.
Because you were a genius for forever.
Yeah. No, you have to talk about, hey, I tried this and it didn't work. I failed on a job, unfortunately. All of us that are early in these things, we failed a lot. You started with your first round of printers and you got rid of all of them because they don't work anymore. You can't just buy the first thing, whatever it is. You can't buy the first thing and, I already spent money on that. I can't go get a different one. Mm-hmm. No, if that was the wrong product, sorry. Like you have to make sure that if you're the one doing the printing or the scanning, or you're the one advising someone to do it, like we have to define the right tool for the right job in order for that job to be successful. And the client likes it. Now they want more. Now they're willing to invest in it. Now, that is how the industry grows, no matter which technology we're talking about.
Absolutely. And just on the side of the education again, I do want to reinforce this. Like the content and the educational content is so valuable, but you got to do it for a long time, which people don't like to do. But yeah, it's so fantastic because I don't know why anybody pays for paid advertising anymore because nobody has any trust in it. It's all over the place. It's garbage. And this is the thing I always look for is like compounding returns. These videos will exist for the next 10 years.
Yep.
And they will hopefully still be reasonably relevant.
Well, and so again,
it builds on itself.
Parts of it, talking about the process, talking about the mindset of pushing through the difficulties and the innovation process and the, content generation and education material, and it's huge.
Yeah. Oh, it's an enormous deal. And it builds on itself, and it's such a valuable way to, like you say, build trust and that kind of thing.
So what's the size or capacity, or explain a little bit of where you guys are at now with your farm, with what you're doing, and even if there's more explanation other than just that you have the 3D printing form, like a little bit of where things are today or going for you.
Well, when the whole thing started, kind of the operational goal for us was, can we make 3D printing more affordable than molding up to 100,000 pieces? Because 100,000 pieces is a nice round number and is more than 25,000, which is what Toyota considers to be mass production. And I think they kind of know what they're doing.
Yeah.
So we ended up crossing that threshold probably about 2 years ago of like, okay, if you're making more than 100,000, you should go with mold. If you're making fewer than that, you should better be looking at printing because there's no reason not to. But now that we've crossed that threshold, the big holy grail of 3D printing is, okay, you can make 100,000 for 50 cents a part or whatever it happens to be. Can you make one completely original part out of the blue for 50 cents a part? Because the technology can technically do it, but again, it gets into that whole factory workflow problem of like, how do you make sure that part is good and up to snuff and the customer knows what they're going to get and they're kind of guided along so something doesn't go wrong? That's kind of what we're pushing towards, is taking all of that scale and now bringing it back down and keeping that same economy, but down at super low volumes. So, because if that works, then you no longer have to do inventories. You no longer have to order 100,000 pieces, keep them on a warehouse shelf for 10 years until they all sell out. You can just say, need a part, and the part ships out and ships to the customer. And it becomes a warehouse where the shelves make the product, which is really, really cool. Right now, what we've got is we've got our main Megafarm here in Boise, which is spec'd out for 3,000 machines when all is said and done.
Woo.
Yeah. Keeps us off the street and out of trouble.
That's a few.
But that facility is going to be kind of the baseline version of that. And since a lot more customers are moving towards those lower volumes, because when they reduce their volumes, they don't have inventory costs, they don't have shipping, they don't have the lost inventory, which is 10 or 20% all the time. So a lot of them are just trending that direction just from the other forces outside of the economics of the process itself. So now we're turning into this distributions and fulfillment kind of center where the warehouse where the shelves make the product. So we're trying to build more of those. So over the next year or so, there'll be a couple more factories opening up around the States. And we want a couple international in the next 3 years so that it gets really interesting, because when you have those fulfillment centers, now you're not even just making stuff on demand, but you're making stuff on demand where the customer wants it. So you're basically teleporting stuff around, which is really cool now.
Because
it's awesome. You don't have to put it on a ship across the ocean. It just appears over there.
It's already there.
It's all kinds of nifty. So that's kind of the next phase, and building out the software to where that's really easy to utilize and plugs into like a Shopify store or your supply system or whatever it happens to be, so that it's as easy to access this capacity as possible. Because while we've made the process stable and scalable now, everything around it now needs to kind of get built up, because it's cumbersome for like a client to come on board and that kind of stuff. And we're trying to make that as easy as possible so that we're invisible for all intents and purposes. You upload a file and you get a part wherever you need it, and that's it. So that's the next 3 to 4 years of work that we got to work on.
Nice. Very cool. Could you briefly explain a little bit again for those that don't have any knowledge, they've never gotten a 3D part printed and sent to them or in their hands, and then, because again, we've talked about like the different types and materials, and obviously there's like aerospace machines that are millions of dollars that are printing metal refined pieces. What is it, as far as durability, usability, when people are ordering from you, or people out there that maybe they would have interest in doing it, like what are the types of things that you encourage people to print with you? What do they use them for? Is it, and then maybe where do they not?
That's fair. Well, as far as how the process works, you remember in kindergarten when you'd roll out clay and make a little coil pot? That's exactly what we do. But our roll of clay is about the thickness of a human hair. And then we just coil that up over time. The machines themselves, the ones that are working with plastic, are basically a hot glue gun mounted on a thing that lays out that coil pot. So it's melting plastic and laying it down in a little bead. That is our process. There are about 4 other processes, and maybe some guys would claim like 24 or something out there, but ultimately you're building up a part one layer at a time. So you take a 3D model, you cut it into layers, and then you say, put down that first layer, put down the second layer, until the part finally kind of grows. That's the fundamental process of any printing process. Right now, as far as our capabilities and what we like to work with, we like industrial hardware and that kind of stuff, because chunky functional parts are really easy to work with and really easy to redesign for printing without a big old hullabaloo. As far as like what it looks like or what it is, they can do any type of part or material that currently exists with molding. Because like with our process, we can use the entire injection molding supply chain to make the raw materials for our stuff. The limitations within it is that you have to be aware of the fact that since it's put together in layers, those layers could potentially be split apart. Because they're just laid and glued together on top of each other. So that creates in engineering, it's called isotropy. So it's a non-isotropic material where it's one strength in one direction and a different strength in a different direction, which is fine. Wood is non-isotropic. Carbon fiber composites are non-isotropic. There's nothing wrong with them. It's just a nature of the process that, again, you got to design for. So if the part is chunky or functionalist and that kind of stuff, it's great. If you're trying to optimize for aerospace and that kind of thing, Printing is taking that over too, but it's a different set of processes where you're able to create impossible geometries that are super lightweight and super optimized. If you're below aerospace grade, $1 million per part kind of stuff, you generally don't want to use it very often. All the traditional machining is kind of fine for that kind of stuff. Right now, industry-wide, we can print metal, we can print composites, we can print paper. Any material you can imagine can be printed, from chocolate to bioplastic. It's all there. They're all at different stages of how useful they are. But yeah, aerospace, probably most metal parts that go, well, I shouldn't say that. A lot of metal parts in aerospace are printed anymore because you can optimize so much. We focus on kind of the lower grade industrial parts just because they're an easier sell. But as far as what it can do do everything. I have not run into a part that could not be produced with printing, unless it was like a bottle cap, where they're going to make 10 bajillion of them and they're exactly the same. And yeah, sure, fine. It's a disposable piece of plastic crap. Sure, I don't want to print that either. Because with us, from like a business standpoint, we don't want to get into something where, we're making 10 million of them and making 0.05% margin on every one of them, because we got to pay the bills. But there's no reason, and molding is fine because it's a different process that has its spot. Uber high scale, plastic bottles and that kind of stuff, molding will always have, or maybe in an iPhone case or something like that. But basically every other part, probably about 85 to 90% of other parts, can and should be produced with printing, because you eliminate all the waste. You don't have all that startup cost, all that risk, and the vast majority of parts will never sell more than 10 or 25,000 units, even if you're in Walmart. Success is very small from what people think it is. They think it's millions and millions of parts. It's very often not.
What's maybe an area, are there any companies or types of parts or things like that you see as like an ideal use that you guys haven't started working with yet that you would like to? Or
we'd love to do more stuff in the print-on-demand industry. And this is all the guys doing like T-shirts and coffee mugs or something. And they used to be big when Facebook ads were cheap. They used to do a ton of that stuff around there. But the merchandise is so interesting because, like, even us sitting right here, we got two options for things to put our logos on. A T-shirt, a coffee mug, and a cap, which have been the same things for the last 50 years. We've all got sock drawers full of T-shirts of fan things that we don't want anymore. Printing allows you to create an actual original product that can be print on demand to where you can really match to your brand and really create something interesting. The problem is that industry hasn't caught up to creatively what can they make, because the great thing about T-shirts is that you've just got a T-shirt and you put your logo on it. So it's easier for the guys who are doing merchandising to grab that kind of stuff, as opposed to what product do I want to create that matches my audience and that kind of stuff. So building out the catalog of things is kind of the onus on us right now.
That's big.
But yeah, it'll be a lot of fun though, because it's a whole different industry that's all set up with like the YouTubers and that kind of thing, who are trying to figure out how to like monetize audiences and get better reach without being another T-shirt in a sock drawer. So that is something we want to push on more, because it's also such a new kind of a category that they're open to trying stuff like printing and don't have any sort of stigmas attached to it from 30 years of by guy, engineering doesn't work, whatever. And there are no engineering requirements. Don't let it break off and choke some toddler or something. That's always good. Make sure it meets good quality standards. But outside of that, there's not like an engineer of like, oh, it's got to be 99.999% perfect.
It's like, can I give this away?
Exactly.
Can I,
Exactly. So that's something we really want to push on. It's been a lot, and it's been fun to work with the folks in that area.
I think that would be a good one. I have a friend who has a startup, and he bought a printer, and he's been making a few things that when he'd go do a stand-up table or something somewhere, he's like, and it's something that no one else has ever created.
Exactly.
And it's like, it is relevant to what he sells, and and it's got his name on it, and very unique and way cheaper than going on and ordering some other big expensive, something. That's cool. I think that'd be a nice one. In fact, we might have to circle back on that if we need we have our conference coming up.
Where some swag.
We like doing giveaways, custom stuff. That'd be fun.
Oh, totally.
What do you think some of the maybe stigmas or hesitations are from people around trying printing for the first time? Or maybe some feedback you would give to those people if they listen to this, they see it, they're like, man, I've kind of thought about trying printing, but what would you tell those people to get them over that hump of giving it a shot?
It's going to be a conversation. Just make sure that you're ready to ask the questions and are ready to organize that. Because if you walk in the door and say, I want this printed, then the only answer we have is like, yes or no. Like, we can't print it or we will print it or something along those lines. But if you're like, come in and say, can this be printed and can we do this? And you have a goal for it, then the conversation can start of like, okay, we can, but we need to tweak this, that, and the other thing, and you got to watch out for this, and this will be kind of the process of that kind of stuff.
So some honest education help and make sure it's not just yes, we want to do it because we're going to sell you.
Yes.
You're going to give some good process there.
Oh, we have to. There's no other way to do it, because if we don't give that feedback, then the customer's just irritated at us at the end of it all. If they say, here's a part, print it, and we're like, we're going to print it and it's going to be garbage, but whatever, then they're going to be mad at us. So why would we even do that? So yeah, if it's going to be a fight, we're not going to fight the thing. But yeah, if they're coming in and are open to some feedback about how the process works, then we're open to helping out as much as we possibly can, because there's no reason to shoot our own selves in the foot, waste a week working for a customer who's never going to come back again because they're going to be mad at us. You pick your battles.
Yeah. Having the capabilities you guys have, I would assume, and I'm just curious to hear too, like that you have you guys worked through trying to think of your own things, to new products, new things to improve existing, I don't know. Yeah. I just think about the printing not being in it, and I'm like, man, I just think about this stuff all the time where I'm like, I wish I had this clip that hold this cord over here. I wish we, something to hold my sunglasses. Like,
yeah.
What does that process look like for you?
All the time. All the time. We have a whole e-commerce side of the business that's like consumer-focused stuff where we throw out those kind of things. Most of it, though, the thing is, most ideas that you have are terrible. It's like, great, you need a sunglasses clip or whatever else it was, but nobody else in the world cares. It's a very specific application. So in the context of like product design, you maybe get 1 out of 10 if you're really good that's like the rest of the world cares about, and probably more like 1 out of 100. But this is really cool because since printing costs nothing to get started, you can try all 100 of those ideas for basically nothing and find the one that works.
You don't have to go fund it first and get investors. And
you don't have to swing for the fence on the first try. You can get a single. It's okay.
Yeah.
So the fact that it's enabled so much experimentation, it makes it a lot more digital in the context of that. Because like if you were building an app and you were a college kid, you build an app, you prop it up there and people say this is garbage, fix it or whatever it was, and then you'd fix it and you push an update. That's never been possible in manufacturing before. And it is now, because you can create a design, people can say, it doesn't hang on my wall right or something, and you push an update, and now every design going forward is updated. So you have this continuous improvement of actual hardware, which is really nifty. And once you find something that works, you're like, oh, okay, they like the kangaroo version or something. Let's create 10 variations of the kangaroo and really hammer in on that SKU. Mm-hmm. So it gives you so much more control to optimize physical products, as opposed to get a mold and 6 months later it's delivered and then we hope we sell a bunch of these things. It also gives customers just a lot more choice. So everything about it is better.
Okay, well, what's the couple that you've tried you're like, I kind of like this?
Or
one. Come on.
Yeah.
There's got to be one.
There's something almost every week because like, we like run a YouTube channel too, and we're always looking for a video. So we're just like, we're going to design a thing because then at least we get content out of the deal. We're working on the world's largest smartwatch, which is a gauntlet. You're like phone plugged into it, and it's a terrible thing that nobody wants, but it's been kind of fun to mess with because it's sort of kind of harkens back to like that childhood thing of like watching a Star Wars thing from the 70s where you're just like, the whole arm. That's exactly what I wanted my whole life all the time. So that's been one of the recent ones. And but of actual like real products, my favorite type of product is something that is a single piece that has a ton of has very great function. So like a golf ball or a smartphone and that kind of stuff, to where it's just so monolithic that it's great, or a coffee mug. These really functional baseline things. And they're really tough to find because it's so easy to get into the weeds of adding stuff on, thinking you're making it better. One of the best products that I've seen recently We didn't design it, but I'm going to promo this designer. This has been around for like 7 years inside of the print world of hobbyists and that kind of thing. But it's called the Baker's Cube. And it's a brick that has every one of the measuring cups around the side of the brick, from teaspoon all the way up to 1 cup. And it's great because it's this one part, and it's not on that stupid daisy chain key ring thing for all your measuring cups. And I love that thing so much. It doesn't work very well. It's really actually terrible to like scoop stuff out of the thing. But it's such a great design, and I wish it could be made better somewhere there. But that's probably one of my favorite products that I've seen around. Of the ones that we've done, there's all kinds of stuff, but it's just stuff. There hasn't been like that. Yeah, that's the perfect thing we've done.
Well, it's probably a cool spot to be though, like you said, content, YouTube, even the stuff that doesn't work or that's ridiculous makes great content.
Way better.
And, people are gonna, world's largest smartwatch.
Exactly.
That'll get some interest, even if it's stupid.
Exactly. Who cares?
That's cool. Well, man, I feel like we learned a lot. I feel like I need to print something now. Maybe come check out the print farm.
Absolutely. We'll give you the nickel tour.
Yeah, we'll have to do something like that. I'm sure I've had people reach out before too and ask about printing stuff. And I'm like, I've got a few connections, but don't know the space deep. So I think our community needs more people to talk to in the printing world.
Pretty much every industry has that.
Yeah. Well, if you could leave some advice for people, and I could say it's a mix. Obviously, you've had a journey from getting into the new technology, going through headaches, innovation, entrepreneurship, building. What would you leave the community with as we exit?
So many folks go for the need to hit the home run. And the response I have to that is that it's much more about compounding interest. Very small gains over long periods of time that then start to look really exceptional, because when you get to the end of that long period of time, those small gains start turning into real big conversions. And that's not something that many folks hearken to because they think the viral video comes overnight when you finally hit the big thing. But it's generally because you did about 200 or 500 videos before that, or just worked at it and honed your craft until you became big and became an overnight success in 10 years. So that's the thing I would say. Look at how you can operate in a way where you get small gains continuously over time so that it's sustainable and so that they compound and build on themselves over time. That'd be my biggest piece of advice to folks.
That is a big one. And I talk about that a lot with people. I completely agree. A quote I've been saying a lot recently or bringing up is Thomas Edison. 10,000 or 1,000 or however many thousands of iterations to get to a light bulb. And then I pose the question to whoever I'm talking to of, at what version would you have quit? Because nobody today wants to go through the difficulties. They want immediate success. And I say it no matter what technology we're looking at in our industry. Someone tried scanning, it didn't work, I throw it away. I bought a scanner, it's difficult, I can't get this data to work, I throw it away. It's like, stop. No, find somebody who knows how to do it. Ask, try again. Find out what you're doing. Like, patience and consistency is what's going to lead to that long-term success. And there are times that people get immediate viral results. Great. One in a blue moon.
Yes, exactly.
It is.
Couple blue moons.
Yes, a few of them. Very rare. And most of it is that you don't see what happens behind the scenes until you see that success. I posted about it yesterday. I was like, even with the attention maybe I'm getting on social now, and people think, man, he just made it. It's like, no, it's been very difficult. It's still difficult today. You don't know all the behind the scenes. You see the awesome stuff. It is a difficult process. And even people in that difficult process, there's times we want to quit. There's times it's so hard, but
it's flipping miserable.
You have to have that path ahead. You have to know that it's going to be difficult and that difficulty and failure is part of the journey. It's not failure. It's a learning process.
Yes, a learning process where you're very controlled about making sure you're getting closer each time. Like when Edison had the 1,000 light bulbs, he wasn't trying 1,000 random things. He's like, that burned out probably because of this. And then so it gets him closer to the main destination eventually, as opposed to just wandering around and deluding himself.
Exactly. Yeah. If you're hitting the same problem over and over and over, then you might want to reconsider, you know?
Yeah, exactly.
You have to learn from it, reiterate, keep going. So love that advice. Thanks for coming and joining us today.
Thanks for having me, man.
I'm sure it won't be the last time.
Sweet.
All right.
Cool.
We'll talk to you soon.
See you later.